Hi everyone, we're going to make a start on the talks now. I just wanted to first of all thank everyone for coming this evening, especially Andrew who's made his way down from Huddersfield. So no pressure, guys. But yeah, big thanks to Policy Expert and the guys there for having us. Great hosts. Massive thanks to our speakers, obviously legends in the Kotlin space. Just in terms of the running order, we have two talks, 45 minutes each. We'll have a 45 minutes each, definitely. Give or take. And then we'll have a short break in between. Pizzas come in, drinks, etc. We'll have some prizes to raffle off, including your book. And then we'll do the final talk. And for those who want to join us, pub afterwards. But I will hand you over to Alessandro from Policy Expert, just for a very quick intro.
Cool, thank you.
Thank you.
Hello, welcome everyone. My name is Alessandro and I'm a tech lead here at Policy Expert. We are an insurtech with more than 1.4 million customers across our products. We have like home, car insurance, and we are also will soon be launching our pet insurance product. As I said, we're an insurtech, so most of our systems are built in-house, and we have our backend servers. They run on the JVM. The majority of them is written in Java, but starting in 2020, we are also starting having some Kotlin, and we are actually loving it. And so yeah, if you guys have any other questions or want to have more information about what we do, please come and talk to us. We are always looking for like new talent. And we have Abbas and Georgina here. So yeah, feel free to reach them and ask questions. And what does he have to say? Well, in case of emergency, the fire exit is just that door, just in front of that door, so nice and easy. Hopefully nothing happens. And toilets are just by the lift. So just go there and then to the left, and then inside the lift, then left to the lift, you'll find the toilet. Cool. Now, without further ado, let me introduce our first speaker, David Denton.
Thank you, everyone. So can you all hear me? Is that brilliant? Perfect. So welcome to Kotlin's elegance section, simple APIs, unusual tactics. Yeah, I'd like to say thanks again to like Ben and the Source Tech people. That's brilliant. I really enjoyed talking with them. And thanks to Policy Expert for hosting us. So, does anyone see the deception in the picture? That's the first question. Open with a question. 5 seconds. 3 seconds. 2 seconds. Second. Hey, Neil.
Is it the top middle?
Is that it? Top middle? It's the hidden deer. That's like a metaphor for what I'm just about to show you. So, you know, it's like hidden things, and some of the things are a bit more evil than this deer. But anyway. Right, so, hey, yeah, welcome. So what are we here today? So we're going to talk about API design, specifically kind of a library API design. But mostly, I suppose, we're all kind of designing APIs, regardless if it's for us, for open source, for customers, et cetera, et cetera. So the idea is to kind of convey some techniques that we've learned over the last 8 years of delivering kind of open source projects in Kotlin, and to see the kind of techniques that we've discovered that you can use using Kotlin language features, which are pretty unusual, and how we kind of incorporated them into our open source work. If nothing else, hopefully you'll walk away today with like, oh, I didn't know you could do that. But nothing else, and that's kind of my minimum. That's my minimum bar. It's pretty low. So always set a very high target. Firstly, about me. I'm David. I'm a technology consultant. I work here in London. I've worked in a couple of decades of like various projects. Then I did I was on the world's first multi-channel internet bank. That was a long time ago. You ever remember WAP phones? Anyone have a WAP phone? That's good. Then I worked in kind of finance for a bit, and I've done like some global e-commerce, and I worked on the COVID-19 app, which was really cool. Most of these days, I suppose you'd show me as a kind of platform architect, I suppose. I go into clients, so help them to deliver Kotlin solutions, and I try and my benchmark is to try and get continually delivered in 15 minutes from like Trump-based development and like commit to production in 15 minutes. So as a way of kind of metric, I actually finished my previous gig on Tuesday and I counted the number of deploys, and there were 8,000 deploys in 6 months. So that kind of thing that you can actually achieve, you just need the right mindset in order to get there. I'm also a Kotlin GDE, among a couple of these retrobates here tonight, which kind of gives me opportunities to go and talk to people about Kotlin, which I love. And they do some amazing kind of work in like the diversity sector, like the Women's Developer Academy and things like that. But I suppose mostly people know me because of H3K and H3K Connect and Talk Panels. I actually did a count of my open source modules on Maven the other day, and I've got 160 that I actually kind of am mostly involved in and kind of steward of, along with a few other people, of course. So that's quite a lot. So I think I've probably, hopefully, over the last 7-8 years, I think we've done 1,000 releases amongst the various ones. So hopefully I'm qualified to come today and talk to you about API design. So, but first, okay, so about elegant deceptions. So why this talk? So this talk, I think, as a company, we've kind of, I've done so many releases of various APIs, and over the last few years, and people keep kind of asking me, oh, how do you do that? And I keep showing these little tricks, and they were kind of kept badgering me, going, oh, well, tell us how you do this, tell us that. So I thought, right, enough, and you're just going to do it in one talk and get it done with, and no one will ever ask me ever again. So that's the main thing. And also, we're going to talk about why Kotlin is a good language to kind of deceive the user. We'll go over what my mantra is for kind of API design, for simple API design. And then the bulk of this conversation, of the talk, is going to be about kind of covering the various things we've uncovered. We're going to say, this is the kind of thing we're looking to do. How does Kotlin let us do it in a kind of weird, kind of unusual way? And then we'll look at a couple of examples for each thing from the open source world about how it's done. So there's a subjectivity disclaimer. So this talk contains programming methods that somebody, maybe you, won't agree with. The advice here may be against what seems to be industry standard practice. However, remember, context is always king. These techniques are ones we've found work effectively when delivering APIs for the last decade. And I've highlighted industry standard practices because as a word of warning, one of my associates, David Wicks, he always says, let's not forget that the industry standard is failure. So don't always believe what you see on the internet. If you're watching this talk on the internet, don't believe me. Let's talk about words. Deception's got a bit of a negative connotation, which is a bit of a shame, really, because the Cambridge Dictionary defines deception as the act of hiding the truth, especially to get an advantage. Which personally I think is a great definition. It's like it's not negative, but we seem to think that deception we kind of associate it with negative things, but if we're using Kotlin, now Kotlin is already deceiving us in quite a lot of ways. So a lot of what you see when you type Kotlin is actually not what's going on under the covers. I mean, obviously under the covers there's like Java bytecode and assembly language, but above that, things like extension functions and coroutines and operator overload and type aliases and infix functions and even values that you would decline in a class, they're all deceptions. They're all basically lies. So what we're going to try and talk to you today is about that good API design is just deceiving with style. So hopefully you'll take that away from this. So the mantra for simple API design. I had a kind of bit of a think, and I came up with 8 things that I kind of thought, I could find pretty pictures to put a slide with. And these are the things I came up with, but they can generally be, I won't go over one by one, but they can generally kind of divide into 2 camps. The first camp is, and it's all to do with your API users. The first one is, how easy is it for your users to understand what it is that your API does? And the second thing to do is, how easy is it for your users to actually operate the thing that you've created? So if you're creating a library, how easy is it to understand, and how easy is it actually for them to use, to test, to extend, all that stuff? And these are the kind of the things you really kind of need to think about in order to make your library design something that people actually enjoy using and hopefully not ask questions about, because questions are, it's kind of a failure. As Ivan, kind of my partner on H3K, always said, when asked about the lack of Stack Overflow questions with H3K, he said, well, that's a feature, not a bug. Hopefully that means that people instead of having to go to the internet or even ChatGPT, and actually ChatGPT doesn't know what it is because so if you want to be lied to about H3K, go and ask ChatGPT because it's special the things that come up. So into the actual techniques. So if we're talking about simple APIs, the simplest API of all is a function. And why is this? Why is it simple? Because a function does one thing and one thing only. And that's the simplest thing you can possibly do. So in kind of purely functional sense, what we can see is that if we're talking about Haskell or one of these other really functional languages, you should be able to tell what an API is doing just by looking at the types. And we use these kind of functions all the time in our work with Kotlin. We use them in collections. We use them, we use them in lets and altos and all a plethora of. But we don't think about how we use them because they're just built in. They're ingrained so far into us. We don't even think they're an API, but they actually are an API. And so the point, I suppose one of the things I'm trying to get across is like, if you can break down your API into small enough pieces that people don't even think about what it is, because the signature of the function that you're giving them is just doing one thing, and you can tell what it's doing just from the function signature, then half of your work is done. Nobody will ask a question about what it does. For instance, nobody's going to ask what a predicate is, because a predicate is performing a test against like a type R, and it's returning Boolean. It's the only thing it can do in a purely functional sense. So how do we extend that? So in terms of like HTTP for K, we defined it, and not using our mechanism, but using like the server function technique. We define it, we managed to boil down HTTP just to a function definition, and in terms of like two actual function definitions. And the first function definition, which is the HTTP handler, there is a request. You take a request and you return a response. That is something that nobody's going to ask questions about at all. The domain types are there. It's a request. It returns a response. What it does is actually in the description. Once you've described the type signature, you've actually described what the thing does. The second interface, or the type that we call, is a filter, and a filter is like a higher order function that takes an HTTP handler and returns an HTTP handler. So that also is just a simple function that we can use to decorate the behavior of an HTTP handler. And then we've got a couple of methods that actually you can use to kind of, once we've defined these tiny little easy to understand concepts, we can combine them together using a simple extension function. And the thing here is that the exposing of just this API, the HTTP handler and the filter, is so simple that there's only two concepts in this bit of code that we need to understand, and those are the things at the top. So if we extend this out a little bit, we can see how we can compose types to gain a minimal API surface. And minimizing the API means your users have less stuff to understand, and that's good for you at the end of the day. So this piece of code below, it basically defines a kind of dynamic HTTP client, effectively. It takes a standard OK HTTP client, it adds some request tracing, some observability, some zipping, does some routing, and then we can apply that client to a request and we get a response. So even though this bit of code is doing quite a lot, it is only exposing those abstractions. It's only exposing HTTP handler and filter, and the domain types of request and response. And we built quite a complex bit of machinery just from those two types. So there's no other classes or options that people need to take care of, but it's just those two things. And that's really the kind of the core of, once you have these small abstractions, it means you can actually build them up, and by composing them together. So it does here look like, request tracing and gzip and retry failures and OKHTTP. It does look like we're constructing objects here. So but actually those bits of code are also only exposing those two. And so moving on, let's just create an object. So this is the simplest piece of code I could possibly come up with in val greeter equals greeter hi. And what we're doing here, we're constructing an object. Okay. But there are no less than 6 ways in which you can actually, I counted 6, that you can actually define this piece of code. I'm going to go through them. Right, so the first one is, as we expect, it's a class constructor. Yeah. So hopefully everyone here will hopefully know what that is, maybe with the exception of Ben. Whoa. The second one is a top-level function with the same name, greeter. Now, the Kotlin style guide technically says that you're not allowed to have a function with a capital letter. But actually there is a get out clause which says the function with a capital letter is okay as long as it's returning the same identically named type of which the name of the function actually is. Second one. Number three, we can actually put an operator function, invoke function on an object. So when you do this, so this is because this allows us to treat this object as a function. You can call it in exactly the same way. From the API user's perspective, it's the same piece of code. They just don't know what's going on under the covers, but it is actually, you could do it in the same way. The fourth one, an extension. So actually we can define a greeter class on the object, the greeter context object. This looks a bit weird, but actually it does have a use. The fifth one is similarly to one of the other ones, which is basically you have an interface and we define a companion object with an invoke method on that class, on the object. It's a slight kind of diversion, but it is actually different and it has a different use case. And the sixth one is a standard kind of extension function which we can put on the companion. Now, 6 different bits of code. 5 of them are the same, 1 of them is not. One that isn't is the class constructor. The rest of them is what we would probably kind of refer to as factory functions. But there is like a power difference, the power kind of dynamic between these two different types, of function. And actually, one of them gives us a lot more, a lot of different options to the actual other one. So let's compare the two. So constructors versus factories. So based on the function type, return type. Using the constructor, the return type is constrained. It can only return the type on the class that you're calling on. If you're a factory function, you are unconstrained for the type that you can actually return. You can return a null. You can return a completely different type. You can return an arrow either or a result k type or whatever it is. You are unconstrained. Custom logic. If you're doing kind of constructors, you can't do custom logic because of the way in which constructors are very, very minimal in Kotlin. I know Duncan keeps trying to actually make it so that no, he looks guilty. So you can actually hack around it, but it's actually quite it's ungainly and it's not nice to use. Whereas a factory function, you can do all the custom logic you like before you actually return the object. There's no constraint. Advanced features like verification on generics, inline functions, any of this kind of stuff, not available on constructor. In fact, in terms of generics, the constructor, if you pass a generic type into a constructor, then that the constructed object has to have the generic type that you have passed into that constructor as a return, as a part of the object that's returned, which is not particularly intuitive, but it is actually true. And then the factory function, you can go for your life and do exactly what you want. You've got inline class, inline functions or verified generics. You can pass in any type generic, you can do any kind of logic. Same again, we've got these kind of, it allows us the freedom to do what we like. Extensibility. If we're using a constructor, any extension that we want to do on it is invasive to the original class that we're actually constructing. We have to put the constructor in the original object, defining the class. With factory functions, once again, we're flexible. We can in the constructors, we've seen those six different options. We can put it in the constructor, we can put it in the companion object, we can put it free floating, put it in another object. It doesn't matter. It's flexible. And finally, it's like use when we want to, and when we say we mean David, because basically. So the question is like, when would you use a constructor? Now, for David, I use a constructor when I want to expose or track a concrete class state. So that means that I want the API user to know that that is the thing that they're creating. Factory functions is, I want to use that when I want to return an abstraction like filter, or I want to vary the model that I'm returning. I want to return a null, or I want to return like a result object, so we said, and I want to validate input. In fact, this kind of dynamic is such that actually the question that I came across was, when would I use a constructor? And actually the answer for me is, only when I'm actually forced. It also leads to when would you create a class? And actually the answer for me is only when I'm actually forced. So each of the different kind of factory functions that we defined, they all have different uses. So they are all completely, we use them in our open source work, and they're completely, all of them have legit use cases. So they might look like a random selection of stuff, but actually they actually do have use. So, example. So we're using server filters, which is the piece of code at the top. The object at the top, we're using that as a object discovery point. So if we take a look at the bottom line of code, we can see server filters.bearer. If we type server filters dot in control space in IntelliJ, we'll get all the different options of the things that are available on the server filters object. And it's not just these two functions, but these two invoke functions. There's actually anything else that somebody wants to actually attach to the server filters object. We can do server filters object dot server filter dot whatever we want, and that will automatically appear in the ID. And then inside that, we've got the bearer author. Now we're using the invoke kind of overloading here in order to kind of provide different kind of secondary constructors, I suppose, for a bearer auth filter. But notice there is no bearer auth class. It's just a filter. These two functions return a filter. They don't return any kind of concrete type. So we're using here the bearer object as a kind of scoping mechanism to keep all of those functions together in order that they're kind of forming a logical unit. So that's kind of one use of how this kind of it's potentially appropriate for this. We could have put them at the top level, but we could have defined them as attention functions. We have options. But if we wanted to use private methods, etc., in here, then we would have to do some kind of pollution, maybe with namespaces, etc. So that's one use. The second use is HPK body types. So in HPK, we have two different types of body in the core. We have for when we are passing in a string, which is effectively maps to when we have the data we want in memory. And we have a stream input, which is when we're potentially streaming an object from a file or from another service. So we're using this companion object invoke here as an alternative option. You can see at the bottom, the user calls body and they pass in the requisite object. They don't know what they're getting back because they're both returning the body. So we've hidden the memory body and the stream body implementations from the user. And that allows us to, if we want to change those things later, because the user doesn't know anything about them, we are free to change them and release a new version of our library with completely different inputs, but the actual API user doesn't know it. Specifically for this particular companion object, we're using this mechanism because we want to use the JVM static annotations. So the JVM static annotations allows us to call this bit of code at the bottom, which is like from Java, we might want to call it a static function. We can't do that in a lot of the other scenarios, which is why we've used this particular mechanism here. So you have to think about, what particular version of your invoke or your factory function is appropriate for what you're attempting to do. And it doesn't mean you can't move them around later. You can, but it's just that you may paint yourself into a corner because you have a particular thing in mind. So discovering and composing. So we talked about discovery before. And let's talk about lenses. So an HPK lens is an object, which is a function. Actually, it's two functions. And those functions are to do with extracting and injecting a particular type into another target, let's call it. You can see there are two different functions. There's one called extract and one called inject. And the first one's called extract, and you take a target and you pass in the target to the function and you get a type out. And in the second one, you're injecting a type and a target and you get a target out. Now, if we're talking purely functional terms and with no other side effects, there's no other way in which the object, you are basically data transforming and extract, you're transforming the data, you're taking target and you're turning it into a type. In the second one, you're taking a type and a target and you're returning a target, which must mean that the type has had an effect on the outgoing object. Yeah. So that's the kind of signature for each of the lenses, but there's kind of two parts to it. That's the kind of eventual lens that people get to use. In order to help people discover the lens, we use like the recipe that we've got on the left. And so the recipe is like, we use this recipe consistently. And this is how it looks. So target. So if we look at target is the object from which we want to extract a particular object, the type, I suppose. These are defined as, say, for a case of an HTTP message, a path or a header or query, etc. Doesn't really matter, but it just defines which piece of the HTTP message we are extracting things out of. And the second one is the mapping. So once we've got that, and let's take query parameter as an example. Query parameter, when you pull out an object out of a query parameter, it's a string. But we might not always want a string. We might want an int, we might want a local date, we might want a Boolean. And so we have this set of functions, which is the mapping. That turns the string into our output object. So that mapping happens, and these mapping functions are defined on the generic type, which we'll see in a moment, and they're used across all of the different implementations. But they allow us to actually the user to discover this kind of lens that they start typing path dot control space. They get a list of the options. Okay, they select their mapping dot. And the third thing, the final bit that actually turns the specification into the lens is the cardinality. Cardinality allows us to say, the cardinality allows us to tell us how many of the thing are we expecting in the object. So it's either optional, or it's 0 or 1. It's required, it's 1. If it's defaulted, it means if the thing's missing, we get a default value, and if it's multi, it will be a list. So it's a consistent recipe that we can use to actually kind of construct those objects, and that's this kind of recipe helps our API user to kind of know about what they're expecting. And once they've kind of configured their recipe, then they get a lens that they can use. So let's see how we can use that in the HPFK API. We have two we've got two flags here. We've got query.boolean and header.boolean. They're both called isApp. And the Boolean function converts the string Boolean into a Boolean. And one's optional, one's required. So what happens at the bit of code at the bottom is that we apply the function, the query and header objects, the values there of both functions, and we apply them to request to extract out that value. So if we don't get the query out because it's an optional, it will return null, and then we fall back to the header. So the kind of nice thing about this particular this approach is that the Boolean function, the int function, the local date function are defined once and once only. And then throughout HPFK, throughout HPFK Connect, they are reused again and again and again. The point is to try and get it so that you are adding one piece of code, and actually you immediately get the advantage of that code everywhere that you want to use it. So if we want to actually define our own function, we can do something like this. We can define a type alias, which is our target, and the BIDI lens spec stands for bidirectional lens spec. But that is a spec on some type of object and a string. So that could be a query or a header or a file or an environment key. So once we've defined this generic, we can actually create our extension function called file, and that file is going to take the string that's going to make a Java file object. And if we want to actually inject, what's going to happen is going to take the file object and inject the absolute path into the object. And how do we use it? Right, so we use two different versions here. But they were both using exactly the same definition that we just described. So environment key is a way of getting, in this case, a file out of the environment, your home directory, or we can get it out of a web form. So you can see the target here is different. We've got an environment and we've got a web form. But it's a single object that we're at, a single definition of this file thing. So the extension is there and it's automatically reused across all of the stuff. It's really quite powerful stuff. Building types safely. Okay, so generally it's kind of, I suppose, accepted that passing a load of primitive types around in our code is bad. Primitive types are kind of the raw, most base level types that our compiler works with. And by definition, they don't actually have any kind of domain meaning. So they're unvalidated, for example. So we try to use things like tiny types and microtypes in order to kind of get around this restriction. Type aliases we could use, but type aliases are a lie because they're just there to rename a particular thing. We saw it in the last thing. We just renaming a more complicated type to a simpler type, and that's fine, but it doesn't actually give us any safety. We have other concerns as well, like parsing object. We want to parse, say in this case, local date. We want to validate that local date is correct. We want to mask PIR to prevent our value being accidentally outputted to some log file in Datadog or Splunk, where it's going to be a nightmare to get rid of, and the European Union are going to come and make really crappy us. There are value classes, which is the example on the left. This kind of gives us partially what we're looking for. I mean, it gives us like the secondary constructor where we can parse, and then it gives us the init method, which will give us a kind of validated instance to make sure that actually what we've got is a correct date, because you're only allowed to have a party after 1970. Sorry, Duncan. So this is fine, but there's loads of boilerplate here. So can we do any better? It turns out we can do better, and so to do better, we can actually turn to something which is an unexpected source, which is a companion object. Now, companion object in Kotlin has kind of grown a kind of reputation as the place that you put static state that you would put in your Java file. So when you convert a Java file to Kotlin, every time the Kotlin converter sees a static method, it rungs it in the companion object. But companion objects are actually much more powerful than just that. Implicitly, when you import a type, you automatically import the companion type, which is really handy. You can pass the companion type because it's an object. You can pass it around as a singleton, and they're not just for static state. Companion objects are fully fledged objects. They can implement things. They can extend object classes. They can inherit behavior. So what that means is that we can actually provide a level of reuse, and that's exactly what we do in values for K, which is something like that. So values for K is a tiny type library from 4candles set of packages. The aim of this is to kind of reduce all the amount of boilerplate that you need to create when you're creating tiny types. The local date value factory that we've got here, because parser date wraps the local date. Local date value factory extends value factory, which is a more generic type. And we can pass a couple of things on. I'll cover those in a moment. But the value factory actually, the generic value factory actually exposes a bunch of methods that are really useful to us. So for instance, we have this list of methods. So these methods are defined once on the superclass. So parser date of local date.now, what that does is that takes that value, it passes it to a validation routine. The validation routine you can see on the top right is epoch.minValue, which is another generic that's applied to a type. It's basically a predicate on a type, another kind of reusable piece of infrastructure. As we said with the constructor, the problem with the constructor or the init method is you can only throw an exception. And we don't always like to throw exceptions. We actually like to return result types potentially, or we want to return a null. The thing is null. We don't want to actually have to try catch blocks. It's not very functional. Everyone, we're trying to get to this kind of less checks or less exceptional kind of behaviors. So you get these of or null, and there's also of result, and there's parse result and parse methods on there as well. So parse methods do equivalently the same thing as the of methods. They just parse the string into the type instead of just constructing it from the actual wrap type. If we, for instance, wanted to support an arrow either class, we could basically go of arrow either, define it once on the generic super type, and every single one of our value types would actually inherit that behavior all in one go. So the other thing that the value type didn't give us was actually masking the PII. So you can see at the top right hand corner when we call the local date value, we pass in this hidden masker. What that means is that if we attempt to just system out accidentally, potentially, that object into the logs, we will get stars because it's basically defined as a PII value, which will hide its accidental from being revealed. If we actually want to get the value out in a string format, we can actually use the show method that is once again defined on the value factory that is shared across everything. So we've got within values for K, there are loads of these, there are different ones for different things. They're completely extendable. We're really reusing the companion objects in order to gain a bunch of functionality in a reusable way. And API users can just define their own. It's really trivial to do. So that's it really allows you to kind of get power out of these types without doing lines and lines of code. And the last thing is basically if we wanted to use the value factory as a singleton, we can pass it. Once again, we have a value method which is exposed as in the same way as the file method. We define a value method that takes the constructor of the companion object into it, and that does the parsing in and out for us. So when we get a type lens, we can actually extract the parser date out in a typed way. So it allows it, all this stuff has like mechanical sympathy. And that's the essence of this, is building really small abstractions and then just building up and building up and building up and combining them in different ways. Instead of building massive abstractions, building small abstractions. Extension semantics. Okay, so extension functions are really, really useful. So everyone loves them. I love them. They're great. So if we want to say convert an int to a base 2, we can do int.encode or string.decode, and that will give us an ability to deception to say, hey, I can take an int and just encode it to base 2, and we can see how we use it on the right. But then if we want to extend that functionality, and we want to do a base 4 implementation, we can do exactly the same thing, right? We can define an encode and decode method in exactly the same way as we did before, but we have to put it in a different package. And the package is a poor substitute for a kind of modular mechanism, because the semantics aren't really the same as what we'd normally do. If we had a particular contract that we would generally want to actually implement, we'd use an interface. So can Kotlin help us to kind of solve this? And it turns out it can, because you can define an interface with an extension function on the interface. So if we reimagine our base 2 and base 4 implementations, we can actually re-implement them in a very, very more kind of modular way, in a way that we can actually say, well, if you want to, if a user, API user, you want to encode something into base any kind of way, you can do, you have to implement the encoding mechanism. And the encoding mechanism contract is encoding. So that does come with a couple of kind of not complications, but it allows us to, because we've introduced more structure around the interface, we have to kind of do potentially a bit more kind of hoop jumping. We've got a couple of ways of using those extension functions. We can either define a type alias, or we can actually just import the base 4 package, for example, will give us, we can say base4.encode. We can see encoding system.encode, and we've got like the type alias at the top, which is defining our base 4 in a global way. If we want to switch everything to base 2, we would just change globals.kt, and that would change the base encoding throughout our entire code base. The second version of the usage is basically with, and you can use the with base 4, and everything inside that block will actually inherit all of the functions from that from the module, from the encoding that you provide. It's quite an interesting technique that we discovered. We use this in HTTP using message formats. Auto-marshalling isn't particularly interesting, but what it actually does is define a kind of base implementation of, if we want to talk in various message formats like JSON or XML or YAML or etc., we can just implement auto-marshalling, and we get exactly the same behavior as before. So we can write, for instance, we have a test that tests that actually the minimum contract for auto-marshalling is actually in here too. And so you can see this we have 2 implementations here, one which is Moshi, which is JSON, and one which is Jackson XML. Exactly the same bit of code, effectively, apart from you're importing a different thing, and the JSON or XML is a different type of string. And bridging the static data, dynamic data divide. So I often think of like data classes like the ultimate in static typing. Not only have we got static interface because we're using a statically typed language, but we're also using, we have to define, like if we're defining values for our data class, we have to define what they are. You know, in the constructor we don't have to define, but generally the answers that you do. And you have to supply those values, regardless of either if you're doing it via a default mechanism or if you're actually doing it via injection via the constructor. And we've got a var there, and you can set the value. So far, so good. But this is not how we use db-config, right? If you want that, yeah, we're not going to hard code our database value. It's going to be, you know, into a db-config. We want to use something a bit more dynamic. So, but when we simply make that data dynamic and we back it with something like, in this case, Redis, we find out that, oh my God, we have to implement like interfaces, and we have to provide an entirely different like kind of mechanism in order to actually just read out. So API user has to call load, for example, at the bottom, in order to load the data out of Redis in order to actually get what they want. And that's kind of a level of complexity that they didn't really want to have to deal with, because they now have to deal with this db-config repo. What's that? Oh my God. And you can see actually in the constructor, we've got, once again, you've got a function, we've got a constructor function or factory function that kind of just returns an instance of the interface. We don't like constructors. And we're having to, in our Redis, when if we want to construct our data class, we actually have to use the DB URL and DB port. We have to use exactly the same names as we had in the DB config potentially. And if we have like 10 different things, we have to deal with 10, we have to write 8 more lines here, and we also have to convert those strings to URLs, or what happens if it's not there? It's a total nightmare. So the question is, can we do better? Can we make from the API user's perspective, we just want to actually create a DB thing in whatever way we can, and then pull values out of it. Why have we made it more difficult for ourselves? So in order to do that, we can use delegated properties. Now, Kotlin normal Kotlin properties are already lying to you. Right. So when you use them, when you define a val or a var, the Kotlin compiler, unless you declare it as a JVM field, the Kotlin compiler will generate a getter and a setter method, and these are used by Java if you call Kotlin from Java. And so Kotlin allows us to basically combine a custom value custom mechanism, custom implementation of this mechanism. And we can use that using the by keyword. Now, the Kotlin standard library has a load of delegates built in. It's got by lazy, which is you can see the version here. It's got by observable. It's got by map. I've probably got a couple more that I don't know about. You can see how we use it here. We've got count 0. If the lazy behavior is to only call a thing when the function is actually called in the first time. So if we call value twice, lazy only kicks in once, and then the value is count 1 and count 2 are exactly the same. So that's how. But how can we use that for our own evil ends? We can use custom delegates. So we've got a kind of contrived example here of strings. What the strings does is provide a kind of randomized seeded value of a string using a seed, and every time you call the getter method, what's going to happen is that you're going to get a different value out. We use the by object read-only property because it's a read-only val. There's also an alternative that does the var, so there's a rewrite property as well. But you can see what happens here. You've got a function which is get value. It passes in the actual reference to the object that the value is actually on, and the property which you're calling. And so the interesting thing here with the property is that you can see the property actually has a name. So whereas in the Redis example before, we had to actually define DB URL and DB port separately in the constructor, we only have to define it once. If we renamed the property name, then the actual property would also come out with a different value. So that allows us kind of a level of reusability that potentially we want. Obviously, if you're going to do that and you've got a dynamic thing at the back end, then if you change you can potentially change a name that potentially will break something. So that's what testing does. How do we use it in open source? So there's a couple of examples. The first one is typed JSON with data for K. Now, data for K is a kind of data-oriented programming module from Fork Handles. And we can use data paper to provide a static interface over a dynamic object. So we use maps, and in this example, we use a JSON node. So what this allows us to do is to take a JSON node, maybe with 100 values on it, maybe with different values under, and provide a static interface over the top of that. So for DB URL, you can see we've got DB URL that's required, and that's the mapping to turn the string into the URI. And DB port we've got required, which is this name. The point here is what we can do is we can take a much bigger object and then only actually interact with fields that we actually want to interact with under the covers. So the alternative maybe for this, if we wanted to modify a value, would be to read all the properties out into a data class and then interact with them and then write everything back into a JSON node again. This actually, what it does under the covers is actually interact directly with the JSON node. If you're pulling a value out, it's pulling a value out of that JSON node. If you're writing a value in, it's overwriting, it's mutating the value under the covers. And you can see here that at the bottom we're providing config.db port, and we actually, when we update that value, the value gets updated in the actual JSON. In the second version, going back to the original example we had back to Redis, is to do with providing like dynamic storage for static things. So we've got a thing called, in HTTP Connect, we've got a thing called a storage property bag and a storage abstraction, which is a read-write abstraction. And much in the same kind of way, we've got like items that we can actually write and read from. And that item, what it will do, it will write a value to Redis using a parsing a kind of a mechanism that is definable. Exactly the same bit of code. If you want to swap that property bag out to use S3, you just literally swap out the implementation under the covers. So the point is that from the API user perspective, they are still only interacting with these ints and with these URIs. They're not having to worry about repositories and Redis and all this kind of stuff. So the API user, we can actually back our DB config objects, and it can implement interfaces if it really wants. They don't have to worry about those details. And that's kind of about what I had to talk about. These are the kind of things we talked about. I'd say try and decompose APIs into simple parts, and then provide for remixing via composition by users, because the thing is you don't know what your users are going to use your stuff for. That's something we've learned over the years, that the easiest way to make an API that anyone can use is to make it very simple to use and make it very simple to build people's own abstractions from. Aggressively high concrete types, that will give you as the API kind of library author kind of the flexibility to do exactly what you want and to actually make the changes you need to without having to worry about backward compatibility, deprecation, etc. Companion objects are real objects too, so just make sure they're not just bags of static state. Beware of namespace pollution via extension functions. They are very useful, but they do come with a cost. And don't be afraid to use Kotlin's feature set, because it's there for a reason, and there's plenty to explore. So, yeah. Right, and that's it. Thank you very much for listening. Are there any questions? I'm also taking questions while I'm thinking.
That's the whole point of the talk, right? No more questions.
Oh, great.
So when you did the importing extension function from a type alias type thing, is that kind of thing usable if you you have a library that contains the different implementations, and then you want a client consumer kind of thing to set the implementation that's being used?
Yeah, you should be able to. I mean, you can. The import is obviously, if you're going to use the imports, then the imports actually, it's probably easier to use where is it? I'll list it. Sorry. There you go. It's probably easier to use the secondary one, which is basically you can get, because you have a handle on the objects, right? And this is why the packaging semantics are very different. They're they're kind of broken in terms of, they're not first class systems, right? It's just some random string up in the that we don't even look at because it's all folded away by hijack. So if you're going to do that, then you can actually say, in a more kind of object-oriented way, this is my encoding that I'm using for this thing. So you can actually, that's just an object you can use, and everything inside that object can be passed around, it can be passed down. The using things in terms of imports is a little bit hairier.
Yeah,
a little bit less. It's definitely less friendly, and it's got more to trip you up with.
Thank you.
You had an example with server filters with objects.
Yeah.
Come back to that.
Okay. Let's go. No. I'm terrible. Come on. How many different that's this guy.
Yes.
Cut that bit out.
Suppose you want this API to allow supporting of custom user supplied server filters.
Yeah.
How would you do that?
This already supports that. You can just as an API user, you can do server filters dot migrate filter. That's it. And automatically get picked up. You can add an extension to any class, and it's just an object.
Okay. I just didn't think about that like that. Yeah.
Not too related, but why there is also a 4K suffix?
Just I don't know.
So that you can't say it.
Yeah, exactly. But I don't know. It's just a thing. So it's like obviously, I think the first one was H50K, and we just kind of oh, there was a log4j, so we thought, okay, it's for Kotlin. So there are various other ones as well. Obviously, there's a Scala version, which actually isn't related at all. There's also HTTP, I think, which is the TypeScript version. I'm not sure what state that's in.
No questions?
We're back. Hello.
Yeah, so like I think it's C#, which provides like namespaces as a native kind of like feature. How do you feel about? Have you got any opinions about whether Kotlin would benefit from something like that, rather than using objects to kind of like namespace?
Yeah, I mean maybe. I mean we're basically misusing this is the entire thing about misusing kind of the language and language features. I mean technically you're not so this bearer auth thing that's against the Kotlin Scala guide because it's like a capital function. You're not meant to have a function with a capital letter. I'm an anarchist, so I'm saying yeah you can. So yeah, industry standard practice, right? Not always the best. But the point is, the real question really for me is like, what does it mean to construct an object? Right? What does it mean? I mean, if you call a function, does it matter? Well, how do I know? What does it mean? There's no bearer auth type. Right? So why do I care? If there's no object state to track, then I have no bearer auth type. And so when I extract this out to a function or manipulate and IntelliJ, it's only done in terms of the filter. So the abstraction is there. There's no like, nobody needs to worry about, oh, what happens when I have a bearer auth class? Because there's no state to track, it's just a function. So it's kind of like a mindset that we've kind of resolved to kind of just kind of give everyone a simpler time by only having the minimal number of types. And that gives us the maximum amount of freedom in actually creating the APIs.
Thank you. Yeah.